Good morning everyone. I am here to present our final year project, which is the quality defect detector using image processing and machine learning. So my group members are Vibhu Jayawardena, Sasindu Lanka Giganage, and myself, Ravindu Devasurendra. So our project was supervised by Mrs. Sujita Gaspe, and since this project is done with the collaboration of Atlas Auxilia Private Limited, we had two external supervisors, engineer Shalika Amartunga, engineer Dayan Hasha, which are working in Atlas Auxilia. Our project objectives were to innovate a system which can be used to identify common errors in Atlas CR and exercise books, which are the cutting errors, damage books, rule printing errors. After that, design and fabricate a system using image processing to rectify the possible errors. Afterwards, design and fabricate a system to alert the operator at the moment. Then to implement our project as a multi-purpose tool instead of being specific tool. Our first component is the web camera we chose, which is an A4 Tech 1080p Full HD webcam with 30 fps with a fixed focus, and then a CPU which we used our own personal computers, the laptops, which has higher processing speed, separate GPU cores, and it was easy to use since the laptops are easily can be taken to any place you want. Then to get the signals from the sensors we have placed, we used an PLC, which is a Highwell H1 series PLC with 16 inputs and outputs. So this was used to take the inputs as well as to give the outputs when a faulty book is detected. Then we used a photo sensor to detect the arrival of a book. So what we used is a Ricoh PK3 5N sensor, which is a true beam sensor. It is accurate up to 5 meters and uses infrared LED 940 nanometer beam. We have also used a proximity sensor to detect the arrival of the book in two different situations. This one is a Ricoh R3JK sensor, which is a capacity proximity sensor. It is accurate up to 50 centimeters range. To indicate the faulty books and the good books, we used an indicator lamp with 4 lights, red, green and orange. It also contains a siren that can be alerted the worker nearby, saying that they have detected the faulty book. The camera mount has been made by ourselves using metal parts that we found in the storage, and we used welding and riveting to make the stand done. We used PyCharm and PyQt5 Designer to write the Python code to this project. The PyQt5 Design is used to create the GUI, and the Highwell Happy program has been used to program the PLC. The Cascade Trainer GUI has been used to train the program for the pictures we have input. Now we'll look at the line detection part. Here you can see the camera has been placed on top of the printed paper. The lines are printed and the camera detects the lines that has been printed on the paper. As you can see, the camera is placed. The lines has been detected by the green lines as good lines. So when an error occurs, you can see here, when there are no rules, it gives the signals as no rules. Next, we will look at the shape detect part. Here you can see the camera has been placed on top of a conveyor. So when a book comes, a capacitive sensor gives the signal to camera to activate. Then it detects, as you can see, the good book as a good book. So it gives a green light as a signal. Here you can see slowly what is happening. And when a book with cutting error arrives, as you can see, an angle has been cut off and it gives a red light signal. The GUI shows the good book as a good book, and then same thing, a good book. When it comes to a faulty book with some cutting errors, here you can see it shows a red rectangle, which is it says it has been detected by as a bad book. After that is the book measuring part. What we do here is we measure the dimensions of the book. So the width and the height has been measured. Here you can see the when a good book arrives, just like the previous one, it shows a green light. It says that the measuring is correct. So you can see when an halfly cut book, a normal CR book that has been cut by like half of the book has been cut off as a fault. So it detects as a bad book and gives a red light. Here you can see from the GUI, a good book has been detected with green rectangle, saying that the dimensions are correct, showing the exact dimensions. And then here again a good book. And then when a faulty book comes, here you can see the height of the book shown as a red marking, which says that the height is wrong and the book is faulty. That's how you detect the measurements of the book from this code. Here again you can see the height has been recognized as a fault. Finally, we come to the cascade training part, which is used to detect the outer appearance of the book. So here you can see the book has been chopped by some kind of a machine. So when it goes under the camera, you can see this is a good book, which a good book, when a good book goes through the camera, it detects as a good. So it detects the parts of the appearance, the outer cover of the book. And when the choppy book goes off, you can see the path has been detected as bad. Here again you can see when the choppy book comes, it says bad on the cover of the book.